This method is used only when the graph of the function is known. The second point we have to remember is suppose I know the graph of the function. Let the graph of the function be this. Draw a line parallel to x-axis. That line cut the graph at only a single point. Then the function is 1 to 1. 1 to 1. Now draw another graph. Draw a line parallel to x-axis. This line cut at 2 points in the graph. So the function is many to 1. Line parallel to x-axis cut only at 1 point of the graph. Then the function is 1 to 1. If the line parallel to x-axis cut more than 1 point, more than 1 point in the graph, then function is many to 1. The third thing you should remember, the graph should be drawn in the given interval of the domain. Graph of function should be drawn in the given interval. That is, graph of the function should be drawn in the given interval. Then the fourth step is check range. Check range of the function. If range is less than codomain, implies function is into. If range is equal to codomain, the function become onto. These are the 4 steps that you have to use. Find the kind of the function using graphical method. First you have to use, this method is used only when the graph of the function is known. Then second, draw the graph. After drawing the graph, draw a line parallel to x-axis. If the line cuts at a single point, cut at only 1 point, the function is 1 to 1. If the line cuts more than 1 point, in this figure it cut at this point and this point, the function is many to 1. Then remember, the graph should be drawn in the given interval of the domain, the range of the function. If range is less than codomain, into function. If range is equal to codomain, the function is pi to the codomain is given -1 to 1. F of x is equal to sin x. It's the closed interval 0 to pi. To the codomain, the closed interval -1 to 1. Check the kind of function. F of x is equal to sin x. F of sin x. For 0 to pi. First draw the graph of sin x for in this interval. That is x is equal to 0 and x is equal to pi. X is equal to 0 and x is equal to pi. The graph of sin x. Okay. Now, so first, then what is the second step is draw a line parallel to x-axis. The line cut at 2 points at this point x and here, 2 values of x. So function is many to 1. Now what is the range of the function? Range of the function is equal to this height. This is 1. This height 0 to 1. 0 to 1. 0 is the minimum value and 1 is the maximum value. This height is the range. R of is equal to closed interval 0 to 1. That is, range is less than codomain. Function is into. To the codomain is given -1 to 1, and function f of x is equal to sin x. So for the first step is to draw the graph of sin x from -π/2 to π/2. That is from -π/2 to π/2. This is a given interval of the domain. So sin -π/2 is equal to -1 and sin π/2 is equal to 1. So graph of sin x for in the interval -π/2 to π/2. Now draw a line parallel to x-axis. It cut only at one point. So the function is 1 to 1. Okay. Now what's the range of the function? Is equal to -1 to 1. This height. The values varies from -1 to 1. -1 to 1. And codomain is the set. That is given -1 to 1. Range is equal to codomain. Function is onto function. So the function is both onto, both 1, 1 and onto. That is bijective. That is implies invertible. So sin x is an invertible function in this range, in this interval, -π/2 to π/2. In the previous case, for 0 to π, that is not a bijective function. The sin x is not invertible in the previous case. So for this interval, -π/2 to π/2, sin x, f of x is equal to sin x is an invertible function. That is, inverse is exists for sin x in this interval, -π/2 to π/2. There is a set of real numbers. Set of real numbers is the domain, and codomain is also set of real numbers. Set of real numbers means open mouth or open interval -infinity to infinity. This is also open interval -infinity to infinity. Set of real numbers. F of x is equal to x plus mod x bijectivity. Okay, now consider mod x. What is mod x? Mod x is equal to x for x greater than or equal to 0, and this is minus x for x less than 0. It's a property of modulus function. Now what is f of x? F of x is equal to x plus mod x. Mod x for x greater than or equal to 0. Mod x become x. That is equal to 2x for x greater than or equal to 0. And for x less than 0, the function become x plus mod x. For x less than 0, minus x plus minus x. That is equal to 0. So we can write the given function f of x is equal to 2x for x greater than or equal to 0 is equal to 0 for x less than 0. Now we have to draw the graph of the function. Okay. For x less than greater than 0, y is equal to 2x. X less than 0, 0. So this is the graph. X-axis itself cuts the graph infinite number of times for x less than 0. X less than 0. If I am drawing a line, this x-axis. For this region, this is not cutting. For this region, is cut infinite number of times for x less than 0. So the function is, that is x-axis itself cuts the graph an infinite number of times, many to one function. Many to one function. Now what's the range of the function? Range R of is equal to the output, the minimum value of the range is 0 along the negative x-axis and increases to infinity. So range is from 0 to infinity. That is from 0 to infinity. Infinity. This is closed. 0 is included. That is range is less than codomain. Codomain is minus infinity to infinity. The function is into function. Codomain is minus infinity to infinity. Range is less than codomain. Function is into function. That is, this function is not invertible. No inverse function is exist for this function. X minus mod x. X minus mod x. So what is f of x? F of x is equal to x for x greater or equal to 0. X minus mod x becomes x. X minus x is equal to, for x less than 0, x minus mod x become minus x. Okay, or f of x is equal to 0 for x greater than or equal to 0. X is greater than 0, the value of the output is 0. For x less than 0, function is 2x. This is the graph. Here, in this graph itself, in this region, for x greater than 0, the x-axis itself cuts the graph infinite number of times. So, many to 1. And what about range? Range is equal to 0. And the graph is going to minus infinity. Minus infinity. The height is 0 to minus infinity. So, the range is equal to minus infinity to 0, and codomain is equal to R, minus infinity to infinity, range less than codomain. Function is into function. This is from R to R. That is minus set of real numbers. F of x is equal to x mod x. X mod x. Okay. So f of x is equal to x into x for x greater than or equal to 0. So x into modulus equal minus x for x less than 0. That is, you can write the function f of x is equal to x square for x greater than or equal to 0 and minus x square for x less than 0. Here the graph is drawn from minus infinity to infinity, since the range is set of real numbers. So for x greater than or equal to 0, x square, the graph of x square going to infinity. This is equal to for x less than 0 minus x square. This is a graph. Now draw a line parallel to x-axis. This line cuts the graph only at one point. So function is 1, 2, 1. Now to check the range. Range is equal to minus 0 to minus infinity and 0 to infinity. So the range is from minus infinity to infinity. Codomain is also R, that is minus infinity to infinity. So function is onto both 1, 1 and onto, that is bijective. Bijective implies function is invertible into the set of domain x such that minus 1 less than or equal to x less than or equal to 1 is equal to b. That is, domain is equal to codomain. Domain is equal to codomain. Then the function is defined from A to B. First one, f of x is equal to mod x. A is equal to domain is equal to codomain is equal to closed interval minus 1 to 1, minus 1 to 1. That is f A to B is implies f from minus 1 to 1, minus 1 to 1. The function is f of x is equal to mod x from minus 1 to 1 and codomain is also minus 1. So let's draw the graph of mod x in this interval. Graph of mod x in the interval minus 1 to 1. Minus 1, 1. When x is equal to minus 1, y is equal to 1, 1, mod 1. X is equal to 1, y is equal to mod 1, 1. So this is the graph. Right. So I draw the graph in this interval. Now to check the function 1, 1 or many 1 to 1 or many to 1. To check the function whether 1 to 1 or many to 1, draw a line parallel to the x-axis. This line cut at 2 points. So the function is many to 1. What is the range of the function? Range is equal to this height. From 0 to 1, 0 to 1, this height. So that is 0 to 1. Range, codomain is from minus 1 to 1, minus 1 to 1. Range less than codomain. Function is into function. F of x is equal to x cube. The same function, just in the function f of x equal to x cube. Now draw the graph. In the interval -1 to 1. X is equal to 1 and x is equal to -1. When x is equal to 1, this becomes 1 and -1. This is a graph. Now draw a line. This is a graph of x cube. Draw a line parallel. This cut, the line cut at a single point on the graph. So function is 1 to 1. What is the range? Range of the function is equal to -1 to 1. That is on to function. Both 1, 1 and 1, 2. Function is bijective. That is invertible. Function are from domain -1 to 1 to the codomain to -1, 1. Check bijectivity. So the function is f is given from f is -1 to 1 domain to codomain -1. So f of x is given as sine of sine inverse x, an inverse function, sine of sine inverse x. We want to check the bijectivity. Now sine of sine inverse x is equal to x. Sine of sine inverse x. Sine of sine inverse x is equal to x. This implies y is equal to x. Y is equal to x. Now draw the graph of y is equal to x. For this interval is from -1 to 1, x, y. So when x is equal to 1, y is equal to 1. X is equal to -1, y is equal to 1, -1. Okay, this is y is equal to x. The graph of y is equal to x. Now draw a line parallel to x-axis. This cut only at a single point. So 1 to 1. What is the range? The range of the function is equal to from -1 to 1. That is implies on to. Range is equal to codomain. Both 1, 1 and 1, 2 function is bijective. Bijective implies invertible. -1 to 1. Check the bijective. If f of x is equal to 2 by pi sine of sine inverse x. So y is equal to 2 by pi into x. That is sine of sine inverse x is equal to x. Okay, now draw the graph. When x is equal to 1, y is equal to 2 by pi. This value is 2 by pi. X is equal to minus 1, y become minus 2 by pi. It's a graph of function. The straight line cut only at one point. Function is 1 to 1. Now check the range of the function. Range is equal to this height. This height is from minus 2 pi by pi to 2 by pi. Minus 2 by pi to 2 by pi. Minus 2 by pi to 2 by pi. But the codomain is equal to minus 1, 1. Range is less than codomain. Function is into function. So this is not bijective or not invertible. Into signum x into ln e power x. And what is the signum function? Signum function, signum of x is equal to 1 for x greater than 0. So it is 0 for x is equal to 0. So the minus 1 for x less than 0. This is the signum function. And consider ln e raised to x. Ln e raised to x is equal to x into ln e. What's ln e? Ln e is equal to log to the base e is equal to 1. So this becomes x. So the function y is equal to x into signum x. So our function y is equal to x into 1. X into 1 for x greater than or equal to 0. Is equal to x into 0 at x is equal to 0. X into minus 1 at x less than 0. In the interval minus 1 to 1. This value is 1. So the line parallel to x-axis cut us at 2 points. Function is many to 1. And range is equal to this height. That is 0 to 1. The codomain is minus 1 to 1. Codomain is equal to set minus 6. Codomain is equal to closed bracket minus 1 to 1. Range less than codomain implies into function. Into function. So the function is not. Now consider y is equal to x cubed into signum x. So what is the function? Y is equal to x cubed into 1 for x greater than 0 is equal to x cubed into 0, x cubed less than 0. So y is equal to x cubed for x greater than 0 is equal to 0 at x is equal to 0 is equal to minus x cubed for x less than 0. Now this is the function. Draw the graph. X, y. S greater than 0, this is equal to x cube. Less than 0 minus x cube. This is from 1 to minus 1. 1 to minus 1. 1. Okay. That is cut at 2 point. Function is many to 1. What is the range? Range of the function is equal to 0 to 1. Codomain is minus 1 to 1. Range is less than codomain. So function is into and not bijective. So not bijective. D by dx. If dy by dx is greater than 0 or dy by dx less than 0, imply function is 1 to 1. If dy by dx greater than 0 or less than 0, then function is 1 to 1. If dy by dx greater than 0 or dy by dx less than 0, conditionally, that is subject to some condition, subject to some conditions, function is many to 1. F is from R to R. Y is given as x cube plus x. Okay, this is our question. The domain is set of real numbers and range is set of real numbers. Now, what is dy by dx? dy by dx, that is equal to 3x square plus 1. The x square, that is the square of a real number, is always positive. Here plus 1 is positive. So this is greater than 0. This is greater than 0. This is sure. So function is 1 to 1. Now, what's the range of the function? Since y is an odd degree polynomial, for an odd degree polynomial, x cube plus x is an odd degree polynomial. So range is equal to set of real numbers. Range is equal to set of real numbers. And codomain is R. So range is equal to codomain. So function is onto. So both 1, 1 and onto. Function is bijective. That is invertible. F of x is equal to x cube minus x. So domain is R and codomain is R. dy by dx is equal to 3x square minus 1. This term x square of any real number is always positive. This is minus 1, negative. This is negative. Negative. For x is equal to 0, dy by dx is equal to 3 into 0 minus 1, that is equal to minus 1, that is less than 0. For x is equal to 1, dy by dx is equal to 3 into 1 square, 3 into 1 square minus 1, that is greater than 0. So dy by dx greater than 0 or less than 0 for at x is equal to 0 and greater than 0 at x is equal to 1. This is conditionally. The condition is imposed. So the function is many to 1. And again range is equal to R. Codomain is equal to R. So function is onto. But not bijective. F of x is equal to 2x plus sin x. Okay. dy by dx is equal to 2 plus dy by dx sin x is equal to cos x. So 2. What's the value of cos x? Value of cos x is between minus 1 and 1. So 2 plus this closed bracket, that is equal to 2 plus minus 1, 1, 2 plus 1, 3. This is greater than 0, that is greater than 0. The interval is 1 to 3. So the function is 1 to 1. Now f of x, what is f of x? Second, f of x is equal to 2x plus sin x. This x is r and sin x is from minus 1 to 1. So r plus minus 1 to 1, that again is equal to r. That is range is equal to r is equal to codomain. So function is onto. So both 1 1 and onto. Both 1 to 1 and onto. So function is bijective. The domain minus 2, 1 by 2. To the codomain minus pi by 2, pi by 2. X is equal to sine inverse 3x minus 4x cube. Check bijectivity. Check. For this function, put x is equal to sin theta. So this become 3, now 3x minus 4x cube is equal to 3 sin theta minus 4 sin cube theta. That is equal to sin 3 theta, or sin inverse 3x minus 4x cube, that is equal to sine inverse sine 3 theta. This is equal to 3 theta. Sine inverse sine 3 theta is equal to 3 theta. What is theta? Theta is equal to sine inverse x. Okay. Now our function f of x is equal to 3 into sine inverse x, or dy by dx. dy by dx, that is equal to 3 by root of 1 minus x square is from minus, and the value of x is from minus 1 by 2 to 1 by 2. So this is greater than 0. So the function is 1 to 1. Domain of the function is minus 1 by 2 to 1 by 2. That means x is an element of x belongs to minus 1 by 2, 1 by 2. So sine inverse x belongs to sine inverse minus 1 by 2, sine inverse minus 1 by 2 into sine inverse 1 by 2. That's the element of sine inverse minus 1 by 2 is equal to minus pi by 6 to pi by 6. So 3 sine inverse means 3 into minus pi by 6, that is minus pi by 2, and 3 into pi by 6. So 3 sine inverse x belongs to minus pi by 2, pi by 2. This is the range of the function. Range of the function is equal to the codomain. Range is equal to codomain. Function is onto. Both 1 to 1 and onto implies bijective.